Hello everyone. So today we are presenting on the topic
Design and analysis of 10 HP 3-phase induction motor.
using ANSYS software. So this research focuses on the analyzing the key performance aspects like efficiency, heat loss, and magnetic behavior of the motor using simulation tools. The goal is to better understand the motor's performance and how it can be optimized for industrial applications. So this presentation is presented by Ganesh Gaikwad, Premule, and Samat Pawar. So this is the index. So this is the points are covered in these presentations. So this is the abstract of the presentations. So mainly, so our research is about analyzing a three-phase induction motor using ANSYS electronic desktop, which is a software that helps in designing and testing the motors under different working conditions. So the main goal is to check how will the motor perform in terms of efficiency, torque, and overall performance, especially for industrial use. So there is a two main tools. The first one is the ANSYS Electronics Desktop, which is used to study the motor design and electromagnetic performance. And second is the ANSYS Mechanical. It is used to do a thermal analysis using different materials with the help of FEA analysis. So, from our analysis, we found that the three-phase induction motor gives first is high efficiency, second is good torque, third one is the reliable performance even in industries where heavy work is done. So this study helps industry choose the right motor depending on their needs, cost, efficiency, and how well it performs. So in the future, we plan to test these results in the real world to make sure they are accurate. Second is explore the new ways to manage heat and reduce stress on the motor parts to make it more durable and reliable. In the introduction, so in the introduction part, there is the induction motors. Three-phase induction motors are very important in both industries and home applications. So they mainly the motors it converts the electrical energy into the mechanical energy. So these motors are widely used because they are in simple in design. Second is strong and long lasting, and third is a cost effective. Uh, so these motors are found in factories and manufacturing units. Second is the farming machines. Third is the heat and cooling systems and home appliances like fans, washing machines, etc. So the three-phase induction motors are mainly in two types: squirrel cage induction motors and slip ring induction motors. So these motors are used for high power applications because it gives the better efficiency, it provides more torque, and perform well even under heavy load conditions. So so the research focuses on our study mainly focuses on the design and analysis of a three-phase induction motors. So our goal is to uh, check the how efficient they are. Second is the how much power they deliver. Third is the how well they handle heat, means cooling performance. So these parameters are helps in industry to choose the right motor depending on their requirements and the budget. Afterwards, so this is the literature survey. This is the reference number. Mainly focuses then methods and key findings. In the research gaps, it mainly focuses on the existing studies. Means first is the limited focus on the performance parameters. Means many studies do not fully analyze how single phase and three phase induction motors perform under different real world conditions. And second is there is less understanding of how changing the design of the motor affects its efficiency, durability, and overall performances. So third is the less research on the thermal management. Means very few studies explore how to manage heat inside the motors effectively, which is important for the reliability and lifespan. After the use of new technologies like IoTs with the motor is still underexplored. Means they can help improve performances and enable smart predictive maintenance. And the last one is a limited study on the long-term use. Means there is a lack of research on the long-term performance and maintain needs of both single-phase and three-phase motors across various working environments. So after that, there is the uh, proposed methodology. So this is the proposed methodology of this research. Then this is the machine data which is used in the ANSYS software to make the motor very efficiently.
So I am Prem Manoj from third year electrical department. So in this activity I am going to design a three-phase induction motor which is rated as a 10 HP and designed with the help of ANSYS software. So we are going to design a three-phase induction motor. So firstly open the ANSYS electronic desktop which I am already opening. Then tap on file and new. So this is are already available. Then go to Maxwell and RMxprt. So here we are click on generate RMxprt solution and then standard, and there are lots of motor are available. So I am selecting three-phase induction motor and OK. So here this project is coming. Then we are simply double click on machine and put our data. I am designing a 10 HP three-phase induction motor. So now that way we can put the values. So these are the machine data. So machine type is a three-phase induction motor. Then number of pole we are taking 4. So here simply 4. So next stray loss factor. So range of stray loss factor is 0.5 to 2%. So I am selecting 0.005. Then frictional losses. So for our machine I am selecting 30 watt as a frictional losses. Then no, window slash is 0 and reference speed 1500 by calculating a formula 120 F by P, and simply apply and OK. Then open stator and double click on stator. So for stator we are given the values outer diameter as a 250, then inner diameter is a 148, then length is 250. So after putting length, so stacking factor is a 0.92. Then select the steel type material. So from the material library we are selecting M1929G material, which is very suitable for industrial motor. So here in search bar put M19. So select this and OK. Then number of slot, so we are taking 48 slot. Then slot type is a 2, which is semi enclosed. Then no need to put these values for our machine. So simply apply and then OK. So this type of stator is ready. So after the stator, in stator we are designing the stator slot. So here is a auto design is a enable. So disable first and then apply. So in message bar some comments are coming. So we will see after that. Firstly design the slot. So all dimensions are here. So these are the dimension. So HS0 is a 0.8 and HS1 1.05, then HS2 12.9, then BS0 2.8, BS1 is a 4.9 and 6.7. So this dimension I am taking and simply apply and then OK. So after that we are designing the winding. So double click on winding and put this data by taking the data sheet. Winding layer is a 2 already there, whole winding. Then parallel branch is a 2. Then conductor per slot 30. Then coil pitch 7. Number of strand is a 2. And wire wrap is a 0.09 mm. Then wire size is 0.97. I double click and open this, and in diameter section search the 0.9. So this is the correct and OK. Before applying, here end insulation is also there, so here no need to change the all parameter, only we are slot linear and fill factor. So fill factor is a 40 to 60 is a best for our motor, so I am selecting 0.45, and slot linear is a 0.3 and 0.45. Then apply and OK. So this is our stator. So now we will move rotor. Stacking factor is a 0.92. Then number of slot we are taking 44. Then slot type is a 2. Okay. Then outer diameter 147.3. Then inner diameter is a 48. Then length is 250, as same as stator length. Then here also selecting steel type as a M1929G. So click on steel type material to assign it. It will take some time. So here in search bar search the M19. So here coming M1929G. So simply OK. So here material is selected. So no need to put these values. OK. Then apply and OK. So this is the rotor dimension. So in that put slot dimensions with the help of this. So HS0 is 0.5. So HS1 is 1.2. HS2 is a 12. BS0 is a 1. Then 5.2. And BS2 is a 3.5. So apply and OK. So slot also ready, and then double click on winding, and here bar conductor type and entering conductor type we are selecting aluminum also, but we are getting high efficiency, so according to that aspect we are selecting a copper C1000. It is a very best material. So copper C1000. So specification of this material is a relative permeability is 1 and conductivity is very high as compared to other. That's why I am selecting this, and thermal conductivity is also high, 396. That's why I am selecting it. So end length is a 0, end ring width is a 20, and then height is a 10. And here also same, assign a copper C1000. So after that apply and OK. So up till now design is OK. So in analysis no setup is there, So right click on analysis, add solution setup, and then here setup 1. So it is important things to operating motor under different operating parameters to getting the results. So I am applying the setup. Here select the constant power, and rated output power is a 7500 because our motor is a 10 HP motor. So here VAT we are given 5500, 7500. So rated voltage is 430. Rated speed is always less than synchronous speed, and synchronous speed formula is a 120 F by P, which is already calculated, and this is a 1500. So we are taking 1415, which is less than 1500, and operating temperature is a 75 degrees Celsius. So in three-phase induction motor, frequency is a 50 and winding type is a star, and OK. After applying the setup, clear all the messages, and then setup is the right click and select setup and analysis. So after that, save the project. So after that, it will be running. So in message manager, message is showing that the normal completion with simulation on a server, means in our motor no any error. So simply right click on setup to take the design sheet of our motor and go to design sheet. So after clicking, design sheet was not generated. That's why I am close the ANSYS electronic desktop and again reopening, and then open where there I am saving the project. So again open the same file, then data sheet will be generated. So right click on setup whenever we want to design sheet of our machine, and go to design sheet. So here design sheet is generated, and whatever deeply parameter we want, that all parameter all are present in that sheet. So go to performance, and here go to rated performance. In rated performance, all the required data is coming. So in that, change the unit watt. So this was the very basic data. So our efficiency is 90.7. So and power factor is 0.9. Then total losses is 768. So we can also reduce it. So highest losses is stator ohmic losses. So we can also reduce it by some changes in input parameter. So we will go for next. Then go to curve. In that curve, here all type of curve are there, means efficiency versus speed, then torque versus speed. So click on all whatever you want, and see the result. This is a torque versus flux weakening by changing each and every point of frequencies. So all type of curves are there, and this is the design sheet. We can also calculate by clicking right click and print. we can also print this print datasheet. So up till now we will design our motor. So for getting the result in a characteristic way, so simply right click the result and create quick report and select any one parameter out of this. So I am selecting torque and OK. So here one graph is there, so right click in that and modify report. So change the parameter. Suppose I will change power and add trace. So in that graph is there, so that why it is called as a characteristics. So in percentage efficiency is there, so add trace, then power factor, then input current. So close it and see, this is a characteristics graph. So right click on torque and rename it characteristics and see the result. So this is the characteristics of our 10 HP 3-phase induction motor, and we can also take a photo by right clicking on that and copy bitmap image. So this is the design of 3-phase induction motor. So next part explaining Ganesh.
So hello everyone, I am Ganesh Gaikwad. Now I am going to explain you the 2D analysis of three-phase induction motor using ANSYS electronic desktop. In that we are using ANSYS Maxwell. So why 2D analysis is important? Because 2D analysis is a important aspect for understanding the magnetic behavior of the motor and the optimization techniques for the motor. And for that we are assigning the AD effect. AD effect is important for every material which is related with the AD current and leakage currents. So first of all, we are creating the 2D design using right click on the analysis tab, then create Maxwell design. In this there are two type of design available: Maxwell 2D design and Maxwell 3D design. Maxwell 2D and 3D are the same outputs, but 3D wants more time for the analysis and 2D wants minimum time for the analysis. So click on OK. Because we are not assigned the AD effect for any part of the machine, there is no any output will show. So we will wait. So all output graphs are blank. For this graph filling, we are assigning the AD effect for the every part of the machine. So select all geometry using Control A, then right click on the geometry, then here is the one tab is there, assign excitation. Inside that one more tab is there, set AD effect. Then inside this, every part of a machine which must be given AD effect is here. So for select all, click on AD effect, then click on OK. Now again analyze all setup. Now wait till the complete analysis. This analysis may take some time. Using this 2D analysis, we are obtaining the some outputs like moving torque, current, voltage, induced voltage for every phase of the induction motor. Then input power is the electrical power which is given to the motor, and the output power is a mechanical power which is taken from the motor. Now after completion of 2D analysis, we are able to see the outputs of moving torque which is damping at the starting and stable at the end. Currents in every phase. This is all three currents are in every phase. This is induced voltage in every phase, and this is a flux linkages for every phase. Input voltage for every phase, and this is a power, which is the red power is showing electrical power, which is the input power given to the machine, and the mechanical power, which is the output. Now after this we want to find magnetic field intensity H and magnetic field density B. So for that, first of all select the all geometry using Control A, then right click on field overlay. After that there is a first option fields. Inside the fields B and H is available. So for B, first of all for B, click on a Mag B, then done. Now fit all. Now we are able to see the output of the field overlay of magnetic field density B. Minimum value is 0 and maximum value is 2074.8181. So same procedure is followed for the magnetic field intensity. So select all geometry using Control A, then right click on field overlay and do the same procedure like a magnetic field density. Done. Now see, the magnetic field intensity is starting from 0 and ending at 7.993 10 raised to 5. So thank you.
This is the result and discussion. In this three-phase induction motor, there is a design, there is a 2D design, there is a 3D design, and there is a field analysis. In this result and discussion, we perform a design and simulation of a three-phase induction motor with 48 stator slots and 44 rotor slots with a rated of 10 HP motors were used. So, in the initial design, there is a basic layout of the motor internal structure. The first figure is it indicates also the stator and rotor geometry, which defines how the motor will perform. So, in the 2D design, this 2D design are we using the ANSYS Maxwell software. It helps to visualize the flux path, slot alignment, and symmetry of the motor design. In the 3D design, it shows the three-dimensional model of the motor. It is useful for the understanding actual geometry, cooling spaces, and internal arrangements. And field analysis are there also. So this simulation shows the electromagnetic field distribution. It helps to analyze the torque generation, magnetic saturations, and overall motor efficiency. So mainly 3 points are come in the from this slide. First is the design and simulation confirm proper alignment and magnetic symmetry. Second is the 2D and 3D models helps to validate performance under different loading conditions. And third is the field analysis supports good magnetic flux distribution, which improves the torque and efficiency. So in the next slide, so result and discussion. So, in the results and discussion, so this graph is mainly indicates the performance characteristics of a three-phase induction motor across a varying speed from the 0 to 1500 RPM. Results and discussion. This is the result we have occurred. The efficiency we are occurred is 93.86 percentage, which is a very good. So in the conclusion and future work, okay, in the conclusion, analyzes this motor in depth means the study deeply examines the induction motor using ANSYS electron desktop and is mainly focuses on the heat, magnetic fields, and energy losses. the three-phase induction motor performance. It offers the high efficiency, better torque, and improved power factor, and it is best suited for the heavy industrial use. Third is the design complexity. While three-phase induction motor are more complex in design, but they provide the better reliability and long-term performances. And next, which is this is the references we are taking. We are take and thank you everyone.